A very good afternoon to everyone, and thank you for joining us for the 21st fortnightly session organized by Knowledge and Awareness Mapping Platform. I, Arika Mathur, convener of CAMP, will moderate this session today. So today we have with us a very special guest, Mr. Onkar Singh Batra, founder and CEO of Paradox Sonic Space Research PSSR International Agency. I welcome you, Onkar. We have with us Mr. Ashish Mittal. He is the project director of CAMP, and my fellow campions. I welcome you all. Knowledge and Awareness Mapping Platform is an initiative and knowledge alliance of CSIR NISPER, that is National Institute of Science, Communications and Policy Research, Ministry of Science and Technology with industrial partner, NISA Communications Private Limited, NCPL. CAMP believes that every student is blessed with a core talent and aims to bring out the best in them through this platform. So CAMP is back with the 21st fortnightly knowledge sharing session for the year 2023 on space entrepreneurship. Space is a growing opportunity for everyone and anyone who is interested in making their dreams a reality. When most people think of space entrepreneurs, they think of billionaires like Elon Musk or Jeff Bezos, who manage significant commercial space enterprises. While they are some of the most well-known entrepreneurs, there are plenty of opportunity for space entrepreneurs in a more mainstream. So entrepreneurship and innovation helps individuals become independent and channel their creativity into creating something of their own in this competitive world. So I hope that you will all learn so many knowledgeable things from this session. So please, my urge to you is to stay till the end of this session. So before we go ahead and invite our special invitee, I would like to appraise you that CAMP organized a scientific excursions on 26th of December at Indian Space Research Organization, ISRO, at UR Rao Space Center and CSIR Laboratory for Paradigm Institute in Bangalore, where students visited the Space Museum Exploration, Satellites Model, greenhouse gases introductions were given to them, global navigation satellite system representation, high performance computing data center visit, and crustal deformation studies were witnessed by these students who visited the CSIR and ISRO laboratories. Last but not the least, please do not forget to give your feedback at the end of this session so that we can keep improving our content. The feedback form can be shared in the form of a video or in the form of a Google form. I hope that you will enjoy this session. So without a further ado, I now invite Mr. Onkar Singh Batra, who is the youngest theoretical author as well as the youngest web developer. Currently at the age of 16, he is the founder and CEO of Paradox Sonic Space Research PSSR International Agency, where he is developing a satellite. Onkar created his first website when he was 7 years old, and by the time he was 12, he had even published his first theoretical book, When the Time Stops. For his accomplishments in 2020, he has also been awarded with the most wonderful award for the students, the Pradhan Mantri Rashtriya Bal Puraskar Award. Recently, under the banner of his company, he has developed a 0.3U sized small satellite communication payload powered by M2M and SatMesh, a patent file technology of the company. This satellite took over 45 minutes flight on board an aircraft at a distance of 10.56 kilometers. With exceptional coverage being received, I would like to congratulate him on the behalf of Team CAMP and CSIR NISPER for his recent success. So over to you, Onkar, and I welcome you on this platform.
First of all, thank you so much for this great introduction. And I really thank the entire team of CAMP, you and Aniket sir, because I guess these kind of initiatives are really important time to time in order to inspire the youth. And it's my honor to be here for the second time. And now an exclusive workshop or and kind of session on the space entrepreneurship. Because by the time India is becoming a leading superpower in the space industry, it's really important to highlight the importance of what we have and what we can give to the space industry and how all of the youth can be a part of this amazing journey. So I start with how I entered the space industry because back in 2020, I realized that the space industry is now being privatized and we have a tons of opportunity to enter the field and then do something. So I guess that was a major exciting part of establishing a company because when I started this project, I didn't start it as a company or maybe as some private domain partner or something, but rather a normal student satellite project. But then I realized that technology, commercialization of technology within India through projects like Atmanirbhar Bharat, Made in India, is really, really important for us to proceed further. So I guess this was a major breakthrough for me and how the company started. And recently, as you mentioned, we did our very first workshop and a very first project that took an aviation flight back 2 or 3 days back. And that was a major success because this is our new technology called SatMesh, and the patent is filed. So this technology is made to create a mesh network in space, and that's what is known as SatMesh. So successfully, it took over an aircraft and almost 10.56 kilometers. It was able to communicate, and it was an exceptional coverage. So I guess this was really interesting part for us. The second project we started is the InCube because I guess we have changed our priorities a little bit. We started with the InCube as a very first student satellite project, and then we realized that we can do something even better or something even more interesting. So we started the SatMesh project, and now our company is developing different kind of payloads and satellites and things. So, this space industry, specifically the Indian Space Research Organization, has opened their new frontiers for the privatization. And specifically, it is known as InSpace, the Indian Space Promotion and Authorization Center. So if there is someone interesting, if you find something interesting, you want to be a part of the ISRO community, I guess InSpace is playing a really big role in that place. So let us say, for sake, you want to develop a CubeSat, just like we did, or maybe you are interested in something like an ISRO workshop, a workshop on radio communications, a workshop on model rocketry. So you can sign up for all these kind of workshops on InSpace website because they are recently promoting youth in space, starting with the privatization, but now they are more focused towards youth in space. So if someone feels interested about these kind of technologies, you should actually, maybe register for them, and you can also contact me or contact my company, and we can help you in that. And I guess recently, what we did, I want to show you the recent payload that we flew on board an aircraft, and this is this payload. So this is one of our new technologies, as I told you, DSSLP, and this is powered on the SatMesh technology. I'll turn off this bit of blur that is coming around. So this kind of technology we have developed, it seems to be a very basic RF payload, but the technology, the algorithms we use can actually power this entire system on board just two single AA cells. So I guess 1.5 volt, that is a total of 3.3 volt power budget. And that too with the regulator of 2.5 volt, you can actually power this particular payload for more than 1 hour, and you can communicate over 10 to 20 kilometers in range, and that too just using a 3 volts battery. So I guess understanding the constraints of what space companies are and what the space industry requires, I guess it is really important to manage and balance those things and then work on the technologies, because just like everyone, we have also faced a lot of errors because everything started with the tinkering, simple tinkering with things, and then enjoying stuff. but that within few period of time that became a more of an interesting idea turned into a commercial innovation. So I guess this was really interesting about how we can enter the field and how we can start with this, enjoy things while actually making some commercial innovations that can help India in becoming a global power in the space industry. Because by the time the private space industry is going to take over the LEO commercial launches or developing of satellites, I guess ISRO and the official government agencies within the Department of Space can focus more on manned missions, something that can make us compete with NASA, and the private industry can take over the commercial aspects. If you have any questions, you can ask me, and then I can move on to the second part of the topic.
Any of the audiences, any of the participants, if they would like to ask anything from Onkar, can directly speak and you know you can raise your questions regarding if you have any doubts, whatever he's explaining. If you have any questions, you can throw, and he will be glad enough to answer those questions. So we have one.
Um, can you show me that model which you made?
If I can. You want me to explain the subsystems?
Yes, please.
Okay, so this is the antenna, a specific rubber duck antenna, and then this is the power system, the single two AA cells, and then this is our chipset inside here. This is our chipset, if you see this one. So this is our specific chipset that has all the technologies on board, which can power the satellite and after that send the data from a high altitude.
You can ask your query.
Sir, I would like to ask that what should be the educational qualification of a person to contribute in space entrepreneurship?
See, I won't be political in this, saying that there is nothing required, but I feel that more than your education qualifications, what matter is your zeal and passion towards any field. It is not just about space entrepreneurship or anything, but if you want to enter the space industry, I guess you should focus on reading more researches. I don't feel that just doing your CBSC, cracking IIT is enough to be a space entrepreneur or a space scientist. I know this is a time by time, part by part, step by step process, but if you're really interested in any research topic, your first step should be reading more and more about it and refrain from taking any specific courses into that. So I never sell courses or I never make courses on how to make a satellite, how to make a rocket, but I really love to inspire and tell more about what is it. So if you're interested, I guess you should go ahead, research on the topic, and the best platform is the research papers. You can look on the Google for research papers because they are more delved into research rather than any walk topic on it. So if you do that, it will take time, but I guess it will be the best way to put your things forward.
Great. I think we should move ahead.
Okay. So I'll talk a bit about the India's first open source satellite InCube. And then at the end of the talk, I'll show you some of the models, some of really cool softwares that our company is building, and something we demonstrated 2 days back on our flight, which was a successful and maybe I would say we overachieved results. So I'll show the softwares to you so you can try to use that a little bit. So back in 2021, we started thinking about developing a CubeSat. So those of you who are not aware of what the CubeSat is, so if you're familiar with the concept of satellites, then a CubeSat is a form factor, a cubic form factor, a small sized satellite that is made in a cubic form factor. And within few minutes, I'll show you that. So we started, thinking about making CubeSat, specifically making small satellites and stuff, because those are exciting, interesting, and I guess everyone is, interested to be a part of a space mission, a space journey. So I remember seeing that movie Mission Mangal, and just fantasizing on how interesting it would be when our satellite would be in space. We would be at a mission control center, looking to receive first of the few signals from our spacecraft. So I guess this is a very interesting topic, and this is how even CubeSats were made. The reason why CubeSats were made back in the early 2000s in the US by Cal Poly and Stanford University's professor. The main idea was to engage students and youth in satellite development. And the easiest way to do is to, take off the extra costings and make this entire technology as accessible and as easy as possible. But still, CubeSats are now being commercialized, and that's why we think InCube has to be born. India's first open source satellite has to be there. So this is how we started with this. We developed a satellite which is totally open source in its proprietary nature. So if you are interested, let us say, to develop a satellite, you don't have a baseline, you can use the InCube's hardware and software as a baseline. On the other hand, if you're interested to know more about the satellite data, which is not open source accessible, then you can go on to the repos of InCube and you can find the real-time data, which is totally in raw format. So you can do anything you want with that. These are few things we started with, and then we made entire subsystems. So the first step, whenever you make a satellite, is to create a flat sat. So I'll show you a flat sat, which is not exactly a flat sat at the moment, but this satellite, if I know a lot of you might be electronics enthusiasts, so you would realize that this is a breadboard, and then there are certain microcomputers. There is an Arduino Uno on board here. So I guess this is like the very, very first step of how you do it. And let us say you are an electronic enthusiast, I guess CubeSats are not even exact CubeSats, but CubeSat model can be a very interesting way to put your hands in space technology, because one of the major trade-offs in the space technology is that you don't have to get mainly into the earth side of it, but also the space side of it. So if there is a small proper electronics that you think would merely transmit radio signals, that is not in the space industry. You have to follow certain guidelines, and then space has certain constraints. You cannot actually make 100 watts transmitter transmit, because that is not realistic and feasible in the space technology, because in space you have very limited power access, right? So you cannot gain more access over that, because the solar panel, the footprints of the solar panels are very limited. So even the solar energy consumption and conversion is really, really limited. So that's why we developed this FlatSat using simple electronics, and we showed in certain expos and exhibitions that how, at least for an entry point of view, how you can enter the space field just by using your simple day-to-day electronics, or I would say tinkering electronics, that a lot of space enthusiasts use. So this is really interesting to delve into. So if I explain the subsystems, this is a magnetic torcus, just in order to, let us say the satellite is in the orbit and it is this and this and this and this. Because of this, the communication is not proper because it is tumbling all around. So what we can do is, using the magnetic field that is generated by the magnetodes in this particular CubeSat and the magnetic field of the Earth, the satellite would not tumble, or at least it would reduce the intensity of tumbling, and then it would be aligned with the Earth's magnetic field. Because of that, the antennas would face towards the Earth. And because of that, there would be a very minimal communication loss. So these are certain things. And then the second is the onboard computer, which is, I guess, ESP32 in here. So this is the Wi-Fi module. We were developing a LAN-based solution for CubeSat. And then this is the major onboard computer, that was a transmitter OBC, and this is the major OBC, and also a power distribution system. So all of the components are commercially available and commercially it can be embeddable, because nothing is being customized in here. There are no such very complex circuitry, rather very simple electronics assembled together. So this is how we start with. But this is not the end. This is just the start, and this is called the flat sat. when you tinker with your electronics, understand what you can do. Second part of developing a satellite is choosing a mission. Once you are done with, tinkering with electronics, and this is for the people who are new to the field. If you already know electronics, you can skip this part. That is totally fine. After that, the second part is to tinker and see what missions you can do. So let us say you make and launch satellite, but the satellite has no missions, right? Then it won't make any sense that you throw a satellite, because it would be no more in a debris, because you just send or launch it just for the sake of fame or something else. There was no scientific reasons present. So it is very important to think what is your scientific mission. And even let us say you don't have a scientific mission, you want to launch it, it is like very probable that your RF committee, which is the IARU, would reject your application because there is no scientific evidence present, why you are launching this satellite. I know sometimes this can be constraints to tinkering, but this is always good, because at the same time, space is full of debris, and we have to understand the importance of launching spacecrafts and the types of spacecrafts we should launch. So I guess this is like one really, really important part of how you would understand that reason of choosing a mission is really important. So let us say our InCube CubeSat has a mission that we want to demonstrate the technology which was never used in space. So the entire bus system was developed in-house. That is not in a proper laboratory environment. So chances are the satellite can fail. So we want to demonstrate whether this satellite is good. Is it possible? Is it feasible for space orbits? And for how much time it would sustain the very hard space environment? Once you choose the mission, now it is the real time. And now this is the most exciting part. When you have to choose the proper electronics, you have to customize your boards, you have to choose your transmitters, and there a lot of research, time, patience goes into. Now you go to a vendor, ask them to manufacture your PC that you designed. Then you have to test it. Then everything went into a vacuum chamber, a thermal chamber, where every electronics is being tested. Let us say if it is in space, in that manner, it is being tested to see whether it would sustain the environment or not. So this is a really important part in the space industry, that your satellite has to sustain those tests, otherwise it won't be launched, because this is the very baselines of testings, that at least it should pass the vacuum test, it should pass the thermal test, it should pass the vibration testing. And after that, once the satellite is launched, then it's another point when you are going to test your
Hello.
entire, yeah. So I guess this is the very important part. Once the satellite is in space, now you have to use your ground stations, your RF knowledge to gain the signals, decode them, and then the very exciting part, when you go forward, decode your signals and see what data you got. So these are the step-to-step guide of how you make, build, test, launch, and operate your satellites. And this is what our companies even do. So if someone is interested in making a satellite, you want to buy a bus, the company can provide you everything from making a satellite to operating it. So we call it end-to-end operations, from making, testing, launching, documentations, and after that, operating after launch. So this is how we did that. And after that, once the Incube project was done, we started making SatMesh, as I told you. I would like to share my screen if it's possible, and I'll show you a dashboard that we developed and we tested it.
You can share the screen.
Yeah. So if can everyone see my screen?
Yes, it's visible.
Okay. So this is how we did our plane launch, and this is how we were able to see and decode the data. This is the front end. This is not the back end. The back end is like more sophisticated, and everything is in non-decodable format. And having a back end is also important, because this is actually a better software, a better version of it. And this is what we used during the flight. So there were around 7 users around the world who were actually testing the software prior to, when the payload was in flight. So I'll talk about every single function in here. So this is the ground station function. The ground station has a GPS, and wherever the ground station is placed, it is able to, show that on the map that where is the ground station located in order to get an idea that where the satellite is. Let us say a satellite is moving apart from like US, it is moving around the US or moving around Canada. So you would be able to understand that by the time we receive this packet or this particular payload, even when I'm talking about payload, there can be two payloads. First of all, the hardware, the satellite, and second payload is the data payload. So right now I'm referring to the data payload. So let us say we got these sensors data and we want to understand when the sensor data was sent. So this ground station thing can help it as that, this ground station, particularly like this one is in Jammu. So, okay, the satellite was going around the Jammu when we received these data packets. After that, this is the SNR, this is signal to noise ratio. This helps us understand, when we are receiving the signal, the strength and the quality of the signal. More positive is it, more the better. This is the RSSI, and this has also similar things. This is about the signal strength. So it like minus 100, if it is closer to minus 100, then it is weaker. If it is closer to zero, then it is, I would say, more stronger. This is the packet count. So number of packets or number of data that were sent during the flight. So 3 days back, yeah, it is 2 days back. So 2 days back, when we did this flight, we received 4,800 packets. Then this is the voltage. The voltage the computer is right now experiencing. This is the boot count, like the times the satellite or the payload got rebooted. And this is really important when a space flight is happening, because let us say this payload was in space, and this payload only has two AA cells. So it won't make any sense if the satellite or the payload is transmitting when there is no ground station. It is just wasting its entire onboard computer processing power and of course the battery. So then what we do is we actually hard code into it when there is no ground station, no need to transmit data and go into deep sleep. So once the satellite is in deep sleep, it is saving power. And how many times it got into deep sleep and after it woke up is what we call the boot count, the times the satellite rebooted. And this is the voltage that we were experiencing that time. Then there were certain ports. So these are the data ports. So we receive 3 packets within 3 seconds, like one packet every second. Let us say the port, there are 5 ports in total, but right now we were using 3. So the port 1 is the health data of the payload. So let us say, this voltage, boot count, RSSI, SNR, packet count comes under the satellite health. That, what is the boot count? How many times the satellite rebooted, that comes under health. What was the voltage, that comes under health, SNR. There were other functions as well, which is not in the front end. Those functions were like, whether the mission sensor was working, true or false, whether the IMU was working, true or false. These kinds of functions shows the health of the satellite. Then the port 2 was the IMU, that is the motion sensing. So where was the satellite? What was the acceleration or the velocity the satellite was experiencing? What was the what was the pointing of the satellite? How many axes it was, like minus 90 degree and minus 40 degree. That comes under the second port, which is all about motion sensing data. And the fifth port is the sensor port. So we were using a temperature sensor, a basic sensor just as a placeholder. So it shows, this is not available at the moment, but what was the humidity, then what was the pressure, what was the temperature that comes under it. Here it is: temperature, pressure, humidity, gas emissions. And after that, we had this gyroscope, magnetometer, accelerometer. That is what I was saying. These are the 3 motion sensing systems of the satellite that, shows us what was the satellite motion. You see, this graph was changing all the time. This was never static. So even you see this particular gap, this is there was a data loss in between. Otherwise, it kept changing because even that airplane was not static. It was not a helicopter, it was an airplane. So it was moving all around. And this was able to, make sure what was the acceleration, what was the velocity while it was in flight. And these are the magnetic emissions. So everything has an electromagnetic field. And when I was also talking about this particular satellite having a magnetocore, so a magnetometer makes us understand like what were the magnetic field emissions, how this magnet was able to, communicate with that and able to orient itself. So magnetometer helps understand the magnetic field around the particular sensor or the particular payload. So this was all about our test flight that happened 2 days back and our technology that we are working on. The main mission of our technology and the main mission of our company is to make sure that we make satellite technology, satellite communication more accessible, and not just more accessible, but more reliable by making communication efficient in real time. Thank you. And I guess the floor is open for any questions.
Any questions? So yes, we have one question from Arav.
Sir, my question is that how your journey started with this space research?
I mean, space was always interesting for me. I was fond of watching Discovery Channel. I guess everyone at that age is so fond of such amazing drama shows and serials that came on Discovery. There were documentaries, there were serials, there were informative sessions. So that really interests me. And I knew I wanted to do something in the field of space sciences, but I was never sure how to start with, because even space science is not a limited field. It is not just about planets or stars, it has different fields. Even there is a space biology. So let us say you're interested in biology, but you don't want to go into the space sciences, you don't want to go into the physics part of that, but you're still interested in the space sciences. So you can opt for space biology, where you can actually tinker with organisms in space environment. So I guess space is for all. If even you can be a space economist, you can be a space reporter, you can be a space scientist, you can be a space engineer, and you can be a space entrepreneur. You can be anything in space, right? So economy is a whole different topic, but you can be a space economist in order to understand the economy of space, and you can be in the space from various domains. So I guess this is one of the major fields, domains which are broadening day by day, and there are various opportunities into it. So while I was interested in a leadership part, I came into space entrepreneurship, but at the same time, I was interested in tinkering with electronics, and with my love for coding and technologies, specifically web technologies, software technologies, I combined everything to become a space entrepreneur and a budding space engineer, I would say.
Amazingly explained, Onkar. It also says that you are the master of you know what you are doing, and you are very clear on the path that you are following. So it's very great to hear all that from you.
Thank you. And I really feel that, I was never sure of what to do, but it was just like I knew I wanted to do. And I guess this is all about passion, as I said. I may not be educationally qualified to be called a space scientist, but I am, zealously and passionately qualified to be a space and entrepreneur and space enthusiast. So I guess what matters is your anything, not the space, but enthusiasm and passion about anything, and that can make you touch the pinnacles of success. And while I am still on a journey to be something, I love to explore, because I feel the life is really too short. And the early you start, more things you explore. Because once you come into your adult life, you comes into the career part, and everything becomes so restricted. So because I started early, I still have a lot of time to explore things, be into different domains. So I'm never sure of what I'm going to do, like let us say 10 years from now, but I am really sure whatever field I go into, I would be a master of it.
Absolutely, absolutely. We all can see it and we can all witness it. We can all learn from you, and you are the inspiration right now here for the people who are watching us here in this session and all over the world, because this is where we go live, and it is being it is being seen by in every parts of India. So it is always said that if you follow your passion, whatever field in which you are definitely going to excel, because it is what you want to do. It is what you want to become. So
Definitely.
there's a question on the chat box which says, please explain briefly about the finance part for being a beginner and at the source.
I guess this is really important. If you go into one of the documents released by NASA, that is, I guess, a 101 guide on how to develop CubeSats. there is a specific section of securing funding. So I know even if CubeSats are one of the cheapest source of developing satellites, it is still really expensive because it can range anywhere from $30,000 to $100,000. That is like um, 20 to 80 lakhs easily. So I guess this is really important. Even when we secured a grant that was around a 16 lakhs grant, still it was like really, really minimum in this technology. And even we just used 2L to develop the CubeSat, and rest was about, other expenses, testing, launching, etc. But I guess while it is really heavy costing, our technology is mainly into making a low cost CubeSat so people can use it. Now, if it comes to funding, I think in India, I haven't seen a lot of grant opportunities or something for developing a CubeSat. So in India, it is definitely so limited, but there are various platforms. If government in coming time allows crowdfunding, I guess crowdfunding can be a great way to secure funding, because you don't need to secure 1 or 2 crores. Rather, you have to just secure 5 to 10 lakhs. If our technology becomes successful, you can make satellite for as low as 1 to 2 lakhs. So I guess it is really possible through crowdfunding. Now in India, crowdfunding is, I guess, restricted or maybe kind of prohibited, but I guess in coming time, there would be tons of opportunities. And by the time space, because I guess this is just a start. So we have to give some time to the administration to work on it, because this is very true. I have been into a lot of ISRO and in space meetings, and I have realized that, we have seen in a lot of times government things remains on paper and nothing happens in true. But I have seen, that in space is really taking initiatives every day. Every day I get email that there is this workshop, that workshop, and they are really trying to engage people as well as the industries into it. So in coming time, I guess in 1 year or so, there will be ton of funding opportunities, and you would be able to secure it. And InSpace is also having a lot of workshops for young students from schools and colleges about introduction to space sciences. So I guess you should look for the InSpace website. I'll put it in the chat, and I cannot actually put it in the chat. So you can actually go try, and maybe that can be the best thing to do as of now. If you be in touch with those in space peoples, within few time you would be able to understand the financials and you would be able to do it.
Okay. There is another question which has come up. Is that from where are you operating? Where is your company situated?
The company is situated in Jammu, while we are trying to, move it, because Jammu does not have that resources available. So because of that, the costing is a bit high. But at the same point of time, we have developed a lot of technologies within Jammu only. So that is a major breakthrough for us, that we developed entire metallic structure, the entire chassis of the CubeSat in Jammu-based vendors from Jammu-based facilities only. But at the same time, we are trying to move to Bangalore or any other city which is actually pioneering in the space technology, because that is like more easier to do. But right now we are operating from Jammu, and we have developed the most of our technology from Jammu only.
Any more questions that you want to ask, Onkar? Because this is the lifetime opportunity that you are getting to know so much about space entrepreneurship and about the space industry, how you can get into it, how you can follow your passion, your career into it. If you have, a will to go into a space industry, or you want to become a space scientist or an entrepreneur, you can directly ask the question and hear the guidance coming right from the person who can inspire and who's inspiring us here on this session. I think we are the audience are done with the questions, and with this, I would like to really thank you, Onkar, for this wonderful session, for the things that you have shown here, the accomplishment that you have achieved till far, and from the team camp and all the young, scientists and young aspires who has joined us today. I wish you all the best and good luck for your future endeavors. I
Thank
hope
you.
to see you further in more interesting sessions, and I will keep inviting you to so that you can, you can inspire us more, and you can showcase us and can show us the improvements and achievements that you have done in the future.
Definitely. I guess that would be a great opportunity, and I'll keep the camp team in loop. And time by time, we'll be introducing more sessions and from more amazing speakers. So I guess that would be a great opportunity. Thank you.
Absolutely, absolutely. So with this, I would like to end this session today. And if you have missed this session, don't worry. Then the recording of this session will be made available to you on the YouTube and on our Facebook channel. Also, the recording of this session will be made available under your student login on our camp website, that is www.camp.res.in. Also, you can get an access to listen to the interesting podcast journals and articles by CSIR NISPER under your student login. Once you go there, you can find these journals and articles under knowledge session. Also, camp is organizing fortnightly sessions every Thursday at 4 p.m. So, and also the achiever sessions on the last Friday of every month at 4 p.m. So we'll keep improving our content, and we'll keep bringing such inspiring and knowledgeable sessions for you. So with this, I would like to end this session today, and thank you, Onkar, once again for being with us. So thank you so much.
Thank you so much.